All right, guys, this is your lab 8 for Newark. Remember, for this lab, what we wanted to do is we wanted to take the lab 7 solutions that we had, the tickers we had left, about 1060, and we wanted to calculate the ROC8, return on capital, the 8-quarter geometric mean of the return of capital, right, for all the tickers from the original list. Now, what I'm going to do here is I'm not going to use the original 1060. I'm just going to do it on all of them. But for your lab, you guys want to use those tickers and then calculate the ROC, the geometric mean for 8 quarters for the ROC on those tickers. Okay, so that's the only difference. To start, I take my magic command that gets me my data. Again, you won't be tested on this. This is just for an easy way for you guys to get the data, right? I run this. Bam. I have my stocks table now. If you click on this, you see a massive table of data. All these tickers, these dates. Okay. From here, I want to first filter out. Now again, you're going to be only applying this to those 1060 tickers. All right, that's the only difference. But what you want to do is from those 1060 tickers is you want to filter out the tickers that don't have 8 quarters, the most 8 quarters recent data, right? Because we're doing a geometric mean, we're doing it on the 8 most recent quarters. We want to only do it on tickers that have data for those 8 tickers, right? For those 8 quarters, right? So this is how I'll do it. First, this column gives me all the dates, but I just want the most recent dates, right? So I believe it's, to get the most recent date, it's going to be, if I just do unique on all the dates, it's going to give me a list of all the dates that are in my data set, right? If I run VV, you'll see it's out of order. So I just want to put it in order. And I'll use the order function for that. All right. Now here, if I run this, I now have all my unique dates in order, and I just want the last 8. So this is a quick way for me to just realize which dates I want. Okay, so I want 2016-03 to 2017-12, right? Now again, I'm going to be doing this on all the tickers in the table, but you're going to be actually doing it on only the 1060 tickers from lab 7, all right? So first what I want to do is I want to create a subset of the original table stocks just for the dates I need, right? So I'll use subset, and I'll take it for anything greater than or equal to 2016-03 right there. All right, so I already limited my data by dates. Okay, next step is to figure out which tickers have exactly 8 quarters, all the quarters worth of data. So there's 8 quarters here in my table DF. I want to identify all the tickers that have all 8 quarters of data in DF. How do I do this? Well, I showed you guys how to use your aggregate function, right? And the aggregate function again is going to be the aggregate function, which has 3 parameters. The first parameter will skip. The second parameter is the table you want to do the summary on. The third parameter is the type of summary you want to do. I want to count up some values. And the first parameter is the 2 columns that you're going to use to do the aggregation. The column to the left of the tilde is basically the column that you want to apply n row to, the column that you want to count up. We want to count up the date column, right? We want to count up the dates, but we don't want to count up all the dates as one big set. We want to count up all the dates per ticker, or the prime column, if you will, because the prime column is where all the tickers are. And that is what goes to the right of the tilde. See that? So basically it's going to count up all the dates, but then group them by the ticker, prime. When I run this, and you can see what AG is, there you go, bam. Obviously I just took the first 6 rows, but basically it creates this table where the first column is prime, the second column is date, even though it's not really date. And what it's showing you is all the unique tickers in prime, okay? That's what goes to, because we grouped by prime to the right of the tilde, and it's showing you the count of each of the dates for that ticker, right? And that's we specified here to the left of the tilde. So here it's showing the ticker A indeed has 8 quarters of data. AA has 8 quarters of data. AABA, etc., etc. Right? We just want to filter for only the tickers that have 8. So I'm going to do a subset on the AG table, and I'm going to filter for by date equals 8. There you go. Right, now if I were to do nrow AG, I have 4,222, and if I do nrow AG2, I have 4,075, right? So we knocked a whole bunch of them out. Now again, I'm doing this on all the tickers. You are only doing it on the 10,060 or whatever number of tickers that passed the test from lab 7, all right? That's the only difference. So from here now, I just want to identify, I just want to get a vector of tickers that indeed, that did make the cut in AG2, which basically means they have 8 quarters of data. And so here I go. So now I have a ticker vector called tick. And now I'm going to create another table from the DF table. And this time only taking the tickers from this DF table that are in the tick vector. And again, I showed you guys how to do this, right? We can use subset. A real simple way to do this is to use the in function, the in command. So if I do prime in tick, right? So now it's going to look for every ticker that's in this tick vector and put that in df2. And now I'm set. I have my df2 table where I can do my ROC calculation. All right. From here, I'm going to split out each of the tables. Right, again, we want it from, go about here, we're starting our first table, our first date is 2016-03. So what I want to do for df2 is I need to first calculate all the ROCs, right? So let's calculate all the ROCs. What is the formula for ROC? It's basically your operating income divided by where are you? Property, GAROS, property, plant, and equipment, plus depreciation, all right, plus your working capital, which is basically total current liabilities, total current assets divided by total current liabilities. All right, and we are done. If I calculate this, you will now see I now have a new column called ROC. All right. So from here, we need to, for each ticker, we need to multiply, we add these values by 1 and then multiply them each, all 8 of them, raise them to the power of 1/8 and subtract by 1, right? We're taking a geometric mean of all the ROCs quarter to quarter. It gets a little complicated to do in a data frame as opposed to data.table, which I haven't showed you guys. So one quick way to do this is to just basically create 8 subtables by quarter, all right? So if I were to do subset starting with 2016-03, date equals 2016-03, and just go from there. All right, just go from there. 2016-03, that's R1. I'm gonna do this 8 times. 2, 3, 4, 5, 6, 7, 8, 6, 9, 12, 703, 706, 706, and the last one, 1712. All right, and we are done with this. So I'm going to change these variables. So I'm going to create 8 little subtables. All right. And from here now, I can do my geometric mean. So if I can create a vector called ROC8, and I can go ahead and apply quarter to quarter the calculation. So if I do 1 plus R1 ROC, right, times the subsequent quarters. So if I want to do this 8 times, 1, 2, 3, 4, 5, 6, 7, 8. This will be R2, R3, R4, R5, R6, R7, R8, right? I want to, whatever this product's going to be, I want to raise it to the power of 1/8. Again, this is a geometric mean as opposed to an arithmetic mean, and I'll subtract by 1. And now I am done. If you type in ROC8 here, I have all my ROC8s, right? Now what I can do is, because of the fact that I have some NaNs and missing data, right, I can just add this back to R8. Any one of these little subtables, R1 through R8. You can use any one you want. And I'll just do R8, ROC8 equals ROC8. Okay. And I could create a final table that is only going to be R8, where is dot finite, where the values for ROC8 are finite, and I only want the ticker, to see the ticker, and I want give me only the ROC8. Boom. Now if you run df3, you now have a set of tickers with their ROC8 values, right? It's that simple, guys. All right, and that's basically how you do the lab. All right. Anyway, I'll see everybody in class. All right, bye-bye.